Hello, everyone. So today we are going to shift from me giving you the linear equation and then you interpret the slope and y-intercept, how things are starting and changing, and then using them for predictions. Today and tomorrow, you guys are going to be creating those linear models. So we're going to be creating the scatter plot and line of best fit. So then you guys can do the interpretation and predictions like you already did Monday and Tuesday. You guys will have all day today and tomorrow to complete all 4 models that are in the college prep Wednesday, Thursday workbook. I'm going to walk through the first one where we are going to use the linear model to predict how big did James actually end up being. And I'm only going to give you his data of how much he weighed for like the first 20 or 25 weeks of his life. And then I'm going to give you Bobby's data, my current puppy who's still growing. And you guys are going to use his data and his linear model to try and make a prediction of how big will Bobby be when he's fully grown. So we're going to go over to the college prep workbook. And I already took out sort of the most frustrating part of this is literally typing in the data into the technology that can help us with our scatter plots and line of best fit. So if you click here, in number 1, that's ideally, you're going to do both of these today. Then you guys can do case 1 and case 2 tomorrow. But if you guys are feeling good, you guys can get a head start and finish all 4 cases in this entire workbook, and you guys kind of have a free day tomorrow. But that's how I ideally would break it up. Do the 2 tables, the 2 by James and Bobby examples today. Then you guys are going to analyze what affects the price of a car more, the mileage on the car or the age of the car. But we're going to walk through this first one. So I'm going to go ahead and click here and open up the data for James and Bobby. Okay, so you guys will see here, I already typed in the weights of James up here in green and Bobby down in here in blue, and we can kind of see their sort of trends already. It looks like James in green was gaining a lot more weight than Bobby was. So I'm going to go back to my workbook and go to the first slide. So this is the table that I already typed in Desmos for you, so you guys don't have to worry about it, where I made X the age in weeks, and I made Y his weight in pounds. So the first thing we need to do, guys, is to go get a picture of the graph of that scatter plot with the line of best fit. And that's where I gave you guys a nice little helpful hint. This is going to be the equation that we use in Desmos to get the line of best fit. Okay, that little squiggle right there is right above the tab in the top left corner of your keyboard. You'll hold shift in that button and you'll get the squiggle. So let's go make that happen. I'm going to go over here. Right now we have both James and Bobby up, but I just want to look at James first. So I'm going to click on these blue circles and take Bobby's data off of the graph. We should still see James. Now I'm going to go down here under number 3, that third little row, and now I can start typing. And I'm going to type in the line of best fit equation. Y1 squiggle mx1 plus b. We put the 1s in there because you see there's a little x1, y1, and then there's a 2 down here. We have to include the 1s so Desmos knows what table we want it to use. So down here I'm going to click y1. I'm going to hold the shift and hit that button above tab to get the squiggle. And then I'll type in mx1 plus b. And boom, we have our line of best fit and the scatter plot. So we're ready to take a screenshot. So on a Chromebook, guys, on your left hand, you'll hold down with Control and Shift and hit that button above the number 6, and it'll take a screenshot for you. Mine's going to look a little bit different, but we will want to take a nice screenshot of the graph and make sure, guys, to include the numbers on the Y and X axis, okay? Sorry, guys, my computer's going to look a little bit different than your process with screenshots. Okay, so I took the screenshot. I'll go back to my workbook, and I'm going to put that scatter plot and the line of best fit right there. So now we can kind of see the trend and the line of best fit for James. Now I'll click to this next slide so we can interpret that model. Well, we actually need the equation for that line of best fit we created. So when we come back here, you're going to notice after you typed in this y1 squiggle mx1 plus b, we got the information we needed right here for m and for b. M is always your slope, b is always your y-intercept. So m, and we can just use the first, just round to 1 decimal, guys. So we can say 1.5 right there for m as the slope, which will always go with x. And then negative 1.3 is the y-intercept. So y equals 1.5x minus 1.3. Whatever came out as m, guys, will always go with x. B will end up there at the end. And now it's time to interpret that slope in a complete sentence, just like you guys were doing on Monday and Tuesday. The sentence is always going to start with whatever our y variable was. Oops, and I forgot to include that on this slide, so I'll address that now. So I put in age for weeks and y for weight. And remember, your interpretation, guys, always starts with the and whatever your y variable is. So the weight of James. And if you notice, guys, I just want us to interpret the slope. We're going to skip the y-intercept. Sometimes the y-intercept, when we do line of best fit, doesn't make sense. So for all day today and tomorrow, I just want you to interpret that number with x. So that's going to be how his weight was changing. So the weight of change was, you're going to tell me if it was increasing or decreasing. Since that's a positive 1.5, he was gaining weight, which makes sense. So the weight of James was increasing by 1.5 pounds. And then you have to tell me, using that sentence done from yesterday, how often was he gaining that weight? Because it's every time the x happens. So it's every time his age in weeks continue to grow. So the weight of James was increasing by 1.5 pounds every week. And now we'll make a prediction. Most dogs stop growing around 40 to 45 weeks old. How big do you think James got according to that linear model? So we made x the age in weeks, and I stopped at 26. So we need to go use that line of best fit to see where is his weight going to be around 40 to 45 weeks old when x is 40 to 45. So we're going to go back to the graph, and I'm going to click on the line and hold, and you can start dragging it to go up and down the line to make predictions. The first number in those parentheses is your x value. So I'm going to keep going until I see that hits 40. Oh, I ran out of space. I'll zoom out once. And I'll go back and click again. And when I get to around 40, it looks like it has him at 60 pounds. If I go to that 45, it has him at like 67 pounds. So it looks to me like, according to this, he's going to be around somewhere between 60 and 65 pounds. At 40 weeks, he will be around 60 to 65 pounds. And the crazy thing is that's super accurate. He ended up weighing about 58, 59 pounds, and that's where he stayed his whole life. Now, you guys are going to do this same exact process for Bobby now. So when we go back to the James and Bobby class example, we're done with James's line of best fit, so we can just exit out. Now we're going to come back here, click on Bobby's, turn off James, and now it's time for the line of best fit for Bobby. But if you noticed, we need to use y2 and x2 because the table says x2 and y2 for Bobby. So down here, I'm going to type in y2 squiggle, which is that button right above the tab, mx2 plus b. Now you guys are ready to take another screenshot of this graph, and you guys will use this m and b to interpret how he's growing. Then you guys can click on his graph to try to make that prediction around 40 weeks.